Hey, hello everyone. Today we are going to solve this daily challenge from LeetCode, Knight Probability in Chessboard. So we are given n cross n chessboard where there is a knight starting at the cell row comma column, and it is allowed to move exactly k moves. Now our knight can move in 8 possible directions, 2 in the cardinal direction and 1 in the orthogonal direction. So what we have to find here is the probability that after making k moves, the knight stays on the chessboard. So as you can see, once the knight moves from its starting position to some other safe position, the problem becomes a sub-problem with another starting position and the moves decreased by 1. So if the problem can be broken into such sub-problems, so it means that we can make use of recursion. And to avoid the time limit, we'll also memoize it and make use of dynamic programming later. So uh, let's start with the code. We'll need a helper recursive function, so it will also return double because the probability that should be returned will be in double. So intn is the size we need it, and then we also need the moves, we need the position, by that we mean row and column. And once we are inside it, so we need to first check whether the current position is inside the board. So that means the row is not less than 0, and also not greater than equal to n because it is 0 based indexing. Similarly, c should not be greater than 0, less than 0, or c should not be greater than or equal to n. If any of these conditions is true, then it means that the knight is outside the board and the probability becomes 0. Now what happens if the number of moves is 0? So basically the knight has moved all the allowed moves, and also it has passed this phrase. That means that it is still on the board. So the probability for this particular move is 1 because it stays here on the on the chessboard and there are no moves remaining to go forward. Now we'll now have the knight move in all 8 directions possible. So for that we can store a 2D array which will have all the possible directions. So that would be 8 cross 2, because one we will need each row will be having two directions for row and column. So this will be a 2D array. Let's start with 1 comma 2, then 1 comma minus 2, then we say 2 comma 1, 2 comma minus 1, then similarly in the opposite signs, so 1 comma 2 minus 1 comma minus 2, and finally for minus 2 also minus 2 comma 1 and minus 2 comma minus 1. So these are all the possible 8 directions in which our knight can move. So we will iterate through this directions array. So for in directions, so I'll also need to declare the data type, so it would be auto. It will return a array of size 2. So what I will do is store the probability of the current position for the number of moves remaining. So I'll just define a probability, double probability 0 by default. So for every move, like there are 8 moves possible from a current position. So if going there is safe, then the probability from that moves becomes 1 by 8. And if any move throws the knight outside the chessboard, then the probability from that moves becomes 0 by 8. So we will add all these 8 probabilities to get the overall probability of the current position. So I will just keep on adding the probabilities of each of the moves, and that would be divided by 8 because there are 8 possible moves. So we'll call back the helper function again. The size of the chessboard remains the same. Then we are one move less than the current move. Then we have to go in the direction of the current direction array. So the first index is for the row and the second index is for column. Here we can see that it will go to the next possible position with respect to this array that we have defined. Now what I forgot here is dividing each by 8.0. So suppose there are only one move, so what happens, it goes from here to here, and there k becomes 0, so the probability returned is 1. So that move was safe, so it becomes 1 by 8. Again here also 1 by 8, 1 by 8, all these get summed by 8 times, and the overall probability also becomes 1, like for this position, and if k equal to 1. So that's why we are doing 8 point like divided by 8.0. Now what we will do is just return this probability, that is our probability. This is our answer. Now we just need to call the helper function with the default values, row and column. I think this is it. We'll try and run this. Okay, there is a compilation error, not found. Okay, I forgot return. So this gets accepted. Now we will implement memoization in it so that there is no repetitive calls. So for each position, there could be k possible, like we need to memoize each cell along with its number of moves remaining. So suppose if the number of moves remaining here was 0, then the probability is 1. But if the number of moves here was something else, say 2, then the probability would have been something else. So we also need to take care of the number of moves remaining at each cell. So we'll have to consider the row, column, and the number of moves. So all these three parameters keep on changing. So we need to memoize on the basis of these three. Now suppose this is position 1, then 1, 2, 3, 4, and if we go on counting in this manner, so this can be stored in a form of one directional array of 64 indexes. Say 64, not 64, here there are 7 columns, so it would be 49 indexes. So I'll just basically our dp will be of size n into n plus 1. So vector and again vector, and since the probability is in double, so we will have this as double dp. Now n into n plus 1, and then we will have the default value double, and the number of columns in each row will be equal to the number of moves, so it should be k plus 1, obviously because they are numbered from 0, so we will have all possible from 0 to k indexes, and the default value will be 1. I'll just pass this in the function calls and also declare it in the function itself. So where here, vector double, and mark here, and then finally here dp is called. Now we will make use of this dp. So if dp, then we need the number of like the number of the cell that we will calculate later, and the number of move is not equal to -1. So suppose I call this key, then we will return dp key and k. Also here I'll do the same thing like this. Now what is key here? So as I explained, the key is the unique identifier of each cell, and that would be key. So if I want to calculate the key of this one, so it would be row number 1 and column number 2. So basically r into 1, so basically r into the number of columns, so r into number of columns, that is n, and then we'll plus column, the current column, and also since it is 0 indexed, so we will add 1. So this is our key, and we can run it now, submit it. So it is good enough solution, and hope you liked it. See you tomorrow.